Hello friends, welcome to my channel EE Coach, in which we discuss electrical engineering questions and answers for interview. So in this video we are going to discuss this question: what is the meaning of phase difference in AC supply? So before we begin the video, let's take a look at the questions that we will discuss in this video. The first question will be, what is phase difference? After that discussion, we will go on to what is the phase difference in AC circuits, and then we will discuss what is lagging or leading phase difference. So in order to discuss the phase difference, let's take a look at the distance between the two waveforms at particular times. Here I am showing the distance between the two waveforms at time 0, that has been shown with a black straight line, and when we move in time we see that the difference of the distance is not constant, it's varying. The black line, the length of the black line is varying, so that is telling us that these two waves are out of phase. Now take another look at these two waveforms. In this case, the distance between the two waveforms at different points of time is not varying and it is same. So that means that these two waves are in phase. Now the next question is, what is phase difference in AC circuits? We have discussed the phase difference in general, and now we will discuss the phase difference in AC circuits. Let's take a look at this waveform. In this case, on the x-axis we have plotted time, and on the y-axis we have voltage or current. In this case, the voltage has been shown in blue and the current is shown in red. Now let's take a look here. The current one, that is the red one, is maximum as 0 point and the voltage is 0 at 0 time. Now moving ahead in time, the current is 0 and the voltage is maximum. Moving ahead, we see that at this point the voltage is 0 but the current is minimum, or we can say that it is maximum in the opposite direction. So that was difference between the current and voltage in phase, because at any particular time the current and voltage were not maximum or minimum or 0 simultaneously, but were the maximum or minimum value were different for both the voltage and current. So we can say that in that case the voltage and current were out of phase. Now the next question is, what is lagging or leading phase difference? We very commonly use this term that the current is leading the voltage or voltage is leading the current. So what is the meaning of that? We'll discuss this now. In this waveform that we have shown here, the blue one is the voltage waveform and the red one is the current waveform, and this black arrow that we have shown, now this is to signify here is that if you look here at the red current waveform, you will find that this blue waveform is like an exact replica of the current waveform, but it is coming after the current waveform. That means the voltage waveform is replica, but it is coming after the current waveform. So we can say that current is leading the voltage, because the current waveform is coming first and then the voltage waveform is coming. So this is basically current is leading voltage. But when is current leading voltage? The reply is that is in the case of inductive circuit. That means that if the circuit has an inductive impedance, in that case the current is leading the voltage. Now in the second case, we can see that this voltage waveform is coming before the current waveform. That means the current waveform is replicating this voltage waveform after the voltage waveform has done its cycle. So in this case the voltage is leading the current. And when does that happen? It happens when there is a capacitive circuit. That means the circuit has a total impedance that is capacitive in nature. Now it may be confusing for you, or you may find it difficult to remember. So there is a simple mnemonics for that: LE, the Iceman. Now in this case, LE represents, L is for inductance, because we know that L inductance is the symbol for inductance, and then in this case E is coming before I. So that means in inductive circuit, voltage leads current. So moving forward, we see that in I, C is for capacitance, but here I comes before E. That means current is leading voltage in case of capacitive circuit. So I think that it will help you remember this fact, that voltage leads current in case of inductive circuit and current leads voltage in case of capacitive circuit. So that was it for this video. I hope you liked this video, and before we leave, let's see what is in the next video. In the next video we'll discuss about the meaning of power factor. I hope you have liked this video and you will share it. I might request it is that you should share this video with more and more people and tell your friends about it so that they can also benefit from this video. If you have any question in your mind that you want to discuss, that you want me to make a video on that question, please write it in the comments and I will make a video on that question. Thank you for watching.